Hello everyone. In this video, we're going to be discussing the hungry cow problem from the 2023 February contest. Before I begin with the explanation and the actual code, I just want to highly recommend actually solving the problem by yourself and attempting it by yourself, just so you get a better understanding of what it would actually be like in a contest, and it will also help develop your coding skills. If you've already done that or just want to get straight ahead to the solution, let's begin. First off, we'll read the problem. Bessie is a hungry cow. Each day, for dinner, if there's a hay bale in the barn, she will eat one hay bale. Farmer John does not want Bessie to starve, so some days he sends a delivery of hay bales, which arrive in the morning, before dinner. So that's one key thing. It's before dinner, so if Farmer John sends hay bales one day, then Bessie can eat that hay bale the same day. In particular, on day DI, Farmer John sends a delivery of BI hay bales with 1 is less than or equal to DI is less than or equal to 10 to the 14th power, and 1 is less than or equal to BI is less than or equal to 10 to the 9th power. One thing I want you to notice is 10 to the 14th is the power for DI, or is the upper limit, and that's a pretty big number in terms of USACO. Normally, the O of n value max is 10 to the 8 operations, so you can't even go in a linear search with that value. So compute the total number of hay bales Bessie will eat during the first t days. And if we look here, we see that t is also 10 to the 14. So we know if we want to get the full solution, we're not going to be complete searching over t. But I will talk about that method just to kind of build up from it. What we do see, however, is that n is only 10 to the 5th power. This means that we'll probably be going with that option by going through n, and that will actually work within the time constraints because 10 to the 5th is less than 10 to the 8th. However, we can't do an O of n squared solution because 10 to the 5th squared is 10 to the 10th, which is not in time. So then it has the input format, right? And we see that we might want to use long. That makes sense. These are pretty big numbers. So I'll show you how we use that when we get to the coding portion. So here's a sample input. One hay bale delivery until day 5. We can see that and the output, and there's some short explanations, but we'll be doing our own with visuals. And another one, and another one. So now let's start understanding more of the problem and developing a first algorithm. Alright, so now we're actually going to be discussing how we can get the algorithm to work. So I've written out some of the basic framework that we learned from the problem. For example, Bessie eats one hay bale each day, if possible, and this is done in the dinner time. And Farmer John sends hay bales. The number of that is equal to B on days D, right? And this is set in the morning. So say Bessie has no hay bales on day 5, okay? And Farmer John sends in 10 hay bales that day. Then Bessie will eat those 10 hay bales, right? Or one of those. So the total hay bales eaten in T days is what we want to find out. And remember that this t is 10 to the 14, whereas this n is 10 to the 5, meaning that t we might not actually we're not going to be able to get in time limit with that. So first of all, let's try solving some of these samples. 1, 5, 1, 2, out 2, right? So 1, 5 just means that by day 5, we want to find out what this is, right? How many hay bales she's eaten. So we can have a track of how many she's eaten. Kind of just have a number line. So on day 1, we get 2 hay bales plus 2. So Bessie's going to eat one of them on day 1. Then she's going to eat another one on day 2, right? And we get no more till day 5. So we got 2, right? Correct. Next one, we're going to have 2 deliveries. Now this time one's on day 1 and one's on day 5, right? So we get plus 2, so she eats one and eats another, right? And nothing till day 5. And on day 5, it actually does count that we eat something, right? So we can eat something on day 5. We get 3 hay bales eaten. and there are still 9 hay bales left, we can't really eat them because day 5 is up, right? So we get 3, and that matches, right? And lastly, we're going to be doing this last example. So 10 hay bales. Trying to eat that, eat that, eat that, eat that. So one thing I want you to notice is how we're just kind of eating as much as we can. Sure, in the real example, Bessie could maybe wait till a different day, but this is just the most optimal way to think about it. Bessie just eats them as fast as possible, right? And this is the best one for that solution as well. So we've eaten 4, 1, 2, 3, 4, and on day 5, we get another 10. So currently we're at 16 with this addition. We eat, and we've eaten 5. And that matches, right? So I'm just gonna go down. So I think one solution that we can look at is maybe what if we just kind of go each day, and if Bessie can eat a hay bale, she eats one. Otherwise, she just sits there, right? So kind of like a 4, 1, 0, 2, T, right? Would basically
If hay bale, hay greater than 0, eat. Okay. Else?
Rest. We'll call it rest when she doesn't eat. Okay. So we'd also need to track whenever the orders come in, or the hay bales come in, right? So we're gonna have a last one, and it's just gonna be 0 because the first order is gonna come on at 0. So if
Last is equal to, I guess this is gonna be an I, right, for the iterator.
and we also need to store how many hay bales are there. So let's just do current hay. This is gonna be 0 since we're gonna continuously increase it. By the time we get to T, we'll have seen however many we can eat, and we're done. And we'll just print eaten, right? And we'll just store eaten kind of like current hay bales. So I think one of the biggest flaws with this algorithm is that we have to iterate from 0 to T. That's at worst 10 to the 14 iteration, right? That is a very big number, and USACO is going to time limit that, right? So that's definitely not the solution. Then let's see what we can do. Let me just erase this. So what we can do, however, is we know that we want to involve n, right? N is going to be our primary way of looking at this. Let's just look at this example for some method of doing it. So we have 1, 2, and then 5, 10. So if we first look at this one, we can see that 2 more hay bales are added. So I think we should be able to just store however many hay bales Bessie eats. Cur hay is equal to 0. And we know we're iterating through n. So for I in n, right? So now, since we're iterating through n, we're going to be getting a delivery every single time this loop gets a new value for I. So we can actually just kind of, no matter what, add some hay bales, right, to the current amount, just kind of store it there. And the amount that we're adding is just going to be b of I. Okay? So that's pretty straightforward. And it's pretty consistent as well. And one thing I want you to know is a lot of times in these USACO problems, especially in the bronze level, the solutions are going to be very simple. Okay, especially for like the easier problems. In most contests, there's 2 easy, 1 hard. In the easier problems, you're not going to have many lines of code, normally like 20 to 40, and it's at heart a pretty simple algorithm. You just have to understand it in the first place to actually solve it, right? So we're going to do if the amount of days till the next delivery, right? Since we know that we're just kind of eating as much as we can till the next delivery, we're just gonna kind of consider till the next delivery, okay? And I think the reason that we'd want to do that is because there's no better way to do it, right? We're going to consider all of the ones she eats. For example, in this example, she just eats as much as she can, and if the 10 is bigger, then she'll just stop at 4, and then we'll consider something else in the next one. However, if it's short, we'll just eat as much as we can, okay? So if the amount of hay, cur hay,
Is less than or equal to the amount of days. So d of I plus 1 minus d of I.
and in this statement right here, I want to kind of ask for you to look for an error, and I'll get back to it, but try and think of one right now, okay? So then, eaten,
And let's just have an eaten variable.
eaten plus equals d of I plus 1 minus d of I. So she's eating as much as she can, right? And then how much is current hay going to decrease by? Current hay, it just equals 0, okay? Because she's ate as much as she could, and it maxes out. And I'm actually just going to change this to a less than, a normal less than. And the reason for that is, when does the delivery come in? The delivery comes in at morning, right? So any hay bales that she gets that day, she can also eat, okay? And we know that delivery is going to come in on the next loop of this for loop. So why not just leave, like in a way, just leave that task for the next iteration? So it's just going to keep it more simple. And the reason that this if statement, the current hay one, is because we want to eat. So for example, we're going to have day 1, 2, 3, 4, 5, with 5 being the target day. Say we have a plus 10 on 5 and a plus 10 on 1, kind of like the third sample input. We're going to eat this one, eat this one, eat this one, eat this one, okay? So actually, we're going to have a plus 4 here. And 4 is less than 5, so she can just eat it all away. However, if it's something like 10, then we're going to just kind of stop at 5, because we want to have, just kind of consider how many hay bales are there. Okay, we don't want to kind of infer too much on that, and it's just going to make it a lot simpler for us. Okay, so we're going to have current hay bales equals 0 since she's eaten all of it. Otherwise, current hay bales must be greater or equal to that, right? So let's just have eaten plus equals this thing. So days of I plus 1 minus days of I. And in this case, current hay bales is just going to minus equal. So it's just going to subtract this value. Okay? And that's just because Bessie's eating as much as she can, but she has some leftovers. So this is just as much as she can. Okay? So looking pretty good so far. And now we're going to get back onto the error I mentioned before. And the error is that we're going till n, or n minus 1, since it's going to be I is less than n, right? But we're going to I plus 1. We're considering the I plus 1 case, right? And what that means is that we're going to get an array index out of bounds error, which is not a good thing. So there's actually a really easy fix. We just do I is less than n minus 1, so that we only go to n minus 2, and then n minus 2 plus 1 is just going to equal n minus 1. And it's all nice. But what do we do about the n minus 1 case, right? We didn't really consider it here. Okay? So let's just kind of write it outside of the for loop. So we have this, and you don't worry about this too much right now. I'm going to go over it again when we actually write the code. So let me just delete it for now. So that n minus 1 case, this is what we have to consider. Notice how in the problem, it actually says that d of I, right, this value, is always going to be less than or equal to t, right? So that means we know that that's the last one, and at that point, Bessie's just on a full-on stretch till we can eat as much as we can till day t. Okay? So here's how that's going to look like. And this is basically the same code as before, but in a shortened sense. So let's just consider the hay bales that actually came in that day at first. And this is just going to be b of n minus 1, right? Then Bessie's going to eat as much as she can. And the way I'm gonna write this time is going to be like this. Eden is equal to the minimum, since we're just kind of considering the smaller of the two values, of t minus days of n minus 1. And in this case, we're not actually getting any deliveries on t most of the time. So let's just do a plus 1, okay? Because we also want to eat on that day. There are some examples where we do get a delivery that day, but in that case, it would be 5 minus 5, and Bessie wouldn't eat anything. However, as we saw here, Bessie does eat something on the day of t, which is another reason we want to add that plus 1. and the other value is just going to be current hay. So the reason we're doing this is because it's a lot simpler to just write in code. It's one line, and it shortens up everything by a lot. Okay, so it's going to just take the minimum of these two values. And then we don't really care about subtracting current hay bale since we're not adding anything more, doing any more calculations. So at this point, we'll just print out eaten. And there we have it. We have the entire outline for our algorithm. So now let's just go ahead and code it up. So now it's time to start actually coding up this solution. And if you're wondering, the IDE I'm using is code blocks. So I've already kind of done some of the initial setup. I'm including bits that slash stdc++.h, and that's just because it kind of has every single package you really need for USACO. And it's a lot more efficient to just type out instead of everything else. However, if you're using some sort of IDE such as VS Code, you might have to do individual ones since it might not support this one, right? So we're also doing using namespace std, and for ease of typing, using ll equals long long, just so we can kind of substitute it. So we're taking an input, we've taken an n and t, and then we've also just taken in all the bales into these arrays. Since we're not adding or removing anything, we don't need a vector. So the first thing we want to do is kind of initialize our variables that we're going to be using. So there's a current hay, and that's just going to start off as 0, as well as the amount that Bessie has eaten, and that's also going to start off as 0. Then we're going to go through all delivery days and see how much Bessie can eat. Okay? So then we're going to have just a for loop from I equals 0. And remember I to n minus 1, because that's going to ensure we don't have any errors. And next, we're just going to start off by updating current hay bales. Next up, we want to see how much Bessie can eat. And the way we're going to do that is by taking the minimum of the current amount of hay, as well as the amount of days between the delivery days. Remember, in this one, we're not eating up including the day that it's delivered, because it's going to make it easier for when we actually go through the loop, and just it's going to be less stuff to worry about. Okay, and then of course we have to update current hay bales because Bessie's eating something. And a quick way to do this is just kind of copy this, because however much was eaten is the amount of hay bales that's gone. And that's it. We just kind of made the big chunk of the code. See how this is only like 25 lines basically? It's super short. Don't worry about like making some big complex algorithm. If you can't make it simple, then maybe it's not the right algorithm. Maybe it's going to have like more room for errors and more bugs. Try and go as simple as you can in USACO. All right. Next up, we're going to be going through the end case. And as we can kind of see in our drawing, we just kind of have to consider only the n minus 1 case. And remember, instead of this days, like the next day. Oh, and I have an error here. Yeah, so the error was I was considering the day before, and that wouldn't be nice since we start at 0. Right? So just make sure to keep an eye out for these errors, right? Everyone makes them. But back to what I was saying, we want to consider the n minus 1 case, as well as instead of just saying the next day minus the current day, we're also going to add 1 just in case some condition like that third sample with the 5 comes up, right? Where you want to eat on the 5th day as well, on the teeth day. So you want to add 1, as well as you're actually eating on that day since there's no delivery coming in. All right. So we're going to just do plus 1. And we're just going to see out eat it. That's it. 30 lines of code to solve this problem, right? Very simple. And let's just submit it to USACO and see how we do. All right, so editing me here. And when I actually did write the code, I made a couple errors. The first one was I didn't actually give the data type for these two variables. I set that here now. Long, right? So I did get some errors for that. And second of all, Here I forgot to make it a plus equals and it's just an equals. So you'd want to change that or just copy the code from the description. Alright, so now it's time to submit the problem and see how we do. And there we have it, how to solve Hungry Cow from the 2023 February contest bronze. So goodbye, I hope you enjoyed that explanation, and I hope that you actually are able to apply what you learned to your own coding endeavors and your own USACO endeavors. And if you need any more help with this problem, feel free to put any questions in the comments. I'll have the code in the description, and check out some of my other videos for more explanations. Bye!